volumes of two cubes shown. So we have a cube that is a volume which is 3x everything to the third, and another little cube, so V1 and V2, which is 7 to the third. Good. So for the difference, V1 minus V2, this is 3x to the third minus 7 to the third. Is this okay so far? They want us to determine the difference between the two volumes, and they are cubes, meaning the volume of a cube is the side raised to the third power. Is this okay so far?
Yeah.
And this is the difference. And they're making it very easy for us, because that means that when we factor it, we need the binomial and the trinomial. Once we identify the binomial, the rest is easy. We always start with a sequence of signs. So we subtract, plus, and then plus. Minus, minus, plus, or plus, plus, minus. Good. Can anyone give us the binomial?
27x.
So the binomial is 3x minus 7. What term we cube to get 3x to the third power is this. What term we cube to get 7 to the third. Now the rest is easy. We square this, 9x squared. We square this, 49. We multiply them, 21x. So let's see if this is okay. Is this okay?
Oh, yeah, you just make it look really easy.
That's what I want to do, always. To make it very easy so you can see how easy it is. Good. 28. Again, write the difference in the areas between the large square with the sides of length x and the smaller square with the sides of length 12. So the same idea. We have A1, which is the side squared, and we have A2, which is 12 squared. Good. So then the difference will be A1 minus A2, which is x squared minus 12 squared. Now we have to think in terms of, it's a binomial, it's in descending order, no greatest common factor, no negative leading coefficient, special product. I always hope for a special product. What could this be?
Is it the difference of squares?
Indeed, of course. And what do I write? Very good.
X minus 20, x plus 20? Or at 12?
Yes.
Plus 12?
That's it. That is it. Perfect. Any questions, everybody? Okay, let's move on. We did 28 and 29. Let's look at 30. Very good. Find C such that the polynomial is the square of a binomial. Excellent. So C, y squared plus 14y plus 1. Perfect. Good. So in order for this to be a perfect square, first of all, I have plus here, so I have to have plus here. Secondly, what number squared is 1? Obviously, it's 1. I don't know what this is, but here's how we think about it. We know that the middle term, which we always have to check, is 2 from the formula times this times 1. But this has to equal 14y. So go ahead.
7?
Very good. That's all there is. Because 2 times 7, of course, it's 7y. 2 times 7 times y times 1 is indeed 14y. So this must be 7y. Excellent. So 7. I meant to say 49. So 49y squared plus 14y plus 1 is indeed 7y plus 1 everything squared. So the first term squared plus 2 times the first times the second plus the second term squared. So C equals 49. Because this term is 7y. This has to be 7y. 2 times the first times the second. 2 times 7y times 1 is 14y. There is nothing else but 7y. Only 7y will work here. 2 times the first times the second. So this is indeed 14y, which we have here. Therefore, 7y squared is 49y squared. So therefore, C equals 49. Very good question. Of course, I did not put something like this on the test. We did not practice these. We're going to use them later on. So I'm going to go back to it, to the idea. That's why I didn't emphasize it right now. Of course, you will not have a problem like this on the test. I did not put a problem that I have not done in class. Of course not. There is no secret. You should always know that moving forward.
Oh, the secret is remembering stuff.
The secret is practicing. Yep, I agree. I fully agree. I will never sit at my desk and say, is there a problem or several problems that I did not do in class? Let me put them on the test. No, that will never be the case. Okay, here it is. So we have 25z squared plus bz plus 16. So this is the same idea. It's just that the variable is in a different place, which is fine. Find all values of b that will make the polynomial a perfect square trinomial. Okay, so the same idea. I know how to factor this. It must be 5z plus 4. This is good and great, but not good enough because I have not checked the middle term. If I don't check the middle term, it means nothing. So what is the middle term here? It's 2 times 5z times 4. 2 times the first times the second. 10 times 4. So this is 40z. But 40z has to equal this. Otherwise, the left-hand side does not equal the right-hand side. So bz must equal 40z. So how much is b?
40?
Indeed. Good.
You make everything so much easier. I guess it's the 2 times the first times the last. I guess I messed that up.
Yes, always remember the rule. Students who remember the rule, they will never, ever, ever go back. So every time we square a plus b, or we square a minus b, of course, the middle term is plus or minus 2 times the first times the second. Always. This is the key. Good. Very good questions. What else should I open? For anybody.
Yeah, unless anybody else has anything to say.
Let me
I
see.
have
You didn't.
6.5 and 6.6 that aren't fully questioned.
Excellent. Let's take a look. If you had questions, I'm sure others do too. Okay. So we answered everything in 6.4, and now you wanted us to go to 6.5.
Yep.
Perfect. Excellent.
Unless anybody else has anything else.
Anybody will speak up, please do. So for now, let's go to 6.5 and see what we have to do there. Very good questions. Let's review. Okay. Good. Here it is. Okay. Factor completely. We have a squared minus 5ab minus 24b squared. Perfect. Good. So this is in descending order, considering a as being the main variable. No greatest common factor, no negative leading coefficient. Luckily, 1, and it's not a special product because this is not a perfect square. This is a perfect square. This is a perfect square. That's why immediately I came up with that. But these are not perfect squares. This is, but this isn't. But 1 is the leading coefficient. So I need two numbers whose product is negative 24 and whose sum is negative 5. I must look at the product first. The product is negative, so I expect the positive and the negative. And now I have to think. I need two numbers whose product is negative 24, of course, one positive, one negative, and whose sum is negative 5.
Negative 8, positive 3.
Excellent. That's all we need. The sum is this, the product is this, so then I have a plus 3b, a minus 8b. You should always, please remember, it takes 5 seconds to verify. Do not put in the answer before you verify it. A squared minus 8ab plus 3ab, 3b times negative 8b. And that's it. When the leading coefficient is 1 and it's factorable, if it is, it doesn't have to be. If it is factorable, smooth ride. If the leading coefficient is not 1, it's a different story. Because I have to multiply and it's a long procedure, I have to replace, la la la. Way more work. Is this okay?
Yeah, thank you.
Perfect. Moving on. Back to, this was 9. Very good. Very good work, Rachel. Let's take a look at 24. Okay, so here we have 180p squared minus p to the 4th plus p, 3p to the 3rd. Perfect. It's a trinomial, but it's not in descending order. I refuse to work on it. Negative p to the 4th plus 3p cubed plus 180p squared. Now I see a common factor and I see a negative leading coefficient. Negative p squared right away. If I don't do this, I will not know how to factor. These steps are mandatory before you do anything. So then I have p squared minus 3p minus 180. We check, this times this, correct, this times this, correct, this times this, correct. Now I'm back to the same situation. It's not a perfect square, but luckily 1 is the leading coefficient. Yay! So I need two numbers whose product is negative 180 and whose sum is negative 3. This is a tough one. Why? Because of this huge number. It's negative. Product is negative, so I expect the positive and the negative. Good. I have to work on this. Now, because the sum is negative 3, the numbers have to be very close to each other. Not one very tiny and one very big. The difference is only 3 units. So they have to be kind of balanced. The difference only 3 units. If it's factorable, I don't know. So I start here. That's one of the reasons why we discussed the prime factorization of a number. And this is huge. Of course, 2. Of course, 90. Of course, 2. Of course, 45. 3. 15. 3 again, and 5. Huge. 2, 2, 3, 3, 5. So I'm going to write them like this. Now I have to group all factors into two numbers that are only 3 units apart, if possible. So let's try. Can we? Can we find two numbers? Again, not all polynomials are factorable.
2 and 5?
Say it again.
2 and 5?
But we have to use them all, because the product still has to be negative 180. We cannot leave anything behind. We have to use them all, absolutely all, and get two numbers, one positive, one negative, only 3 units apart. But we have to use everything. And I have an idea. Do you? Using all of them. And they are quite close. 3 units apart. That's why I wrote them like this. We normally don't, right? We normally write 2 squared times 3 squared times 5. But I wrote them like this so it's easy to see. What am I telling you? What numbers am I telling you?
I have no idea.
What is this number? What is this number? What is this?
12?
Good. What is
15?
this? Very good. Are they 3 units apart?
Yes.
Perfect. So I need 15. No, I need 12 and 15 because the sum has to be negative 3. It's guaranteed that this product is this because I used all the factors. It must be. So then, from here, I'm going to jump over to the next page. I have the negative p squared in front, and I have the x plus 12. I'm sorry, p, of course. P plus 12 and p minus 15. The tough part here was this number, because it's large. I had to use the prime factorization tree. I had to decompose 180 into prime numbers. I did not write them condensed. I wrote 2, 2, 3, 3, 5. And then I thought, they have to be balanced, close to each other, not 5 and 25, because 5 and 25 are very far apart. But 12 and 15 are 3 units apart. So then I said, okay, what if I take the 15 and 12? What else could I have done? 20 and 9, not good. 10 and 18, not good. So I made some trials and errors.
Thank you.
Is this better?
Yeah, I need to get better at doing the tree.
Good. Okay, let's see 26. So what is this? Is this your answer or their answer?
That's probably one of my wrong answers.
Okay, no worries, no worries. Factor completely. Okay, so let's take a look. P squared Q squared plus PQ and minus 6. Okay, good. Let me start here a new video.